we go, homework, 3-5. This little symbol that you're seeing here, the exclamation point, these are called factorial symbols in math, okay? And what a factorial does is it's just going to, what it symbolizes, like 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, all the way down. So it's just shorthand for that. You can find that button on your TI calculators. You have a math button. If you hit that math button, at the top of the screen, you're going to see a couple of different names of columns. If you go over to the PRB column, move your cursor over to PRB, which stands for probability, number 4, you're going to see that exclamation or that factorial symbol. Okay, so you can access those that way. Here's a common mistake. Somebody would, to type in this on the calculator, they go and get the factorial symbol, type that in, and then they do 4 factorial, and then they do division, and then they do 3 factorial, and then 5 factorial. So this is going to give you the wrong answer for this statement up here, simply because this is dividing by all of this down here, and in the way we have it typed in down here, it's only getting divided by this 3 factorial. So if you're gonna use your calculator, you're gonna need to put some parentheses around the denominator to make sure everything gets divided by both of those factorials. If you want to do it without a calculator, it's not that hard. Let me go ahead and, since I've already got 6 factorial written up here, so there's 6 factorial. I'm going to multiply that times 4 factorial, which is 4 times 3 times 2 times 1. So that's what I'd have on the top. On the bottom, I'd have 3 times 2 times 1, and times 5 times 4 times 3 times 2 times 1. So I have all that written out, and a lot of this cancels out. So like all this 5, 4, 3, 2, 1 could cancel with that 5, 4, 3, 2, 1. That 3, 2, 1 could cancel with that 3, 2, 1. And all I'm left with is this 6 up here, this 4, and there's nothing left on the bottom. So I just got really 6 times 4, which is going to equal 24. Now you should get the same thing if you type that in correctly with your calculator. Okay, but those are factorials. And let's move on to the next problem where we use those again. So you're going to be, in these next problems, we're using, you get this notation. This is for a combination, and this is for a permutation. Okay, so it's important that you know the difference between these combinations and permutations. One of them, order matters, and the other one doesn't. Okay, so order matters for a permutation. Okay, order doesn't matter for a combination. And so what I mean by that, let's say all of y'all have used a combination lock. So let's say your combination is 20, 10, 7. That's your combination. The order there matters. So really, it shouldn't be called a combination lock. It should be called a permutation lock. Okay, because if you tried to type in 7, 10, 20, it's got the same numbers, but it's in the wrong order. So this wouldn't open your lock. Okay, that is the same combination of numbers, but it's a different permutation. All right, and so, and that'll make more sense as we move on into these things and look at some word problems. But but you have some formulas here that help you determine the number of combinations or the number of permutations. So what this first one is saying here, let me erase some of this stuff. So what this first one up here is saying is, if I have, that's a combination, and the 9-5 means if you're given 9 things, how many different ways could you choose 5 of them? Okay, so my example I always like to use is I go to a pizza restaurant. I've got 9 different toppings to choose from. I get to choose 5 of them. How many different pizzas can I pick? Okay, 9 things, and I'm going to choose 5 of them. That would be because the order would not matter there, right? So that would be a combination. No matter what order I choose them in, they're still going to be the same pizza. So here is the formula for this. Okay, where the 9 is going in this spot and the 5 is going in this spot. So that's just really 9 factorial divided by 9 minus 5, which is 4 factorial, and then 5 factorial. So I could use it. I could, at this point, go to my calculator and do that. I could sit here and write all this out, all the way down to 3, 2, 1, and then down here I'd have 4 times 3 times 2 times 1, and then I'd have that's a lot of stuff. I could sit there and do that. So if I did it that way, longhand way, like I used to have to do in school, I could cancel those 5s. Then I could say 4 and 2 is the same as 8. So nothing. Oh, that 3 will go into 9 3 times. So what that leaves me with is just a 1 on the bottom, and 3 times 7. This whole thing is 21. So there's 21 ways. If I had 9 things and I wanted to choose 5, and the order didn't matter, there's 21 ways to do that. Okay. Now you have that ability to do this on your calculator too. Okay. So if you want to do that on your calculator, you don't have to go through all that. Then if you hit you hit the math button. Hit the math button, go on over to PRB, and you look down to 2, what is that, 2 and 3, yeah. Numbers 2 and 3 are going to be number 2 is your permutation one. So you see this. And number 3 is your combination one. All right, in order to use those, you're going to need to type this number, that first number in, then go access that that program in your calculator, and then the last thing you do is type that number in. You'll get used to it. But so you don't have to memorize these formulas. I don't expect you to memorize these 2 formulas. I do expect you to know how to determine these values using your calculator. If you like to use the formulas, those formulas will be given to you. You'll have access to those. But this is just a matter of understanding what these things mean. Okay, so this is permutation here would be I've got 7 things and I'm only going to choose 4 of them. Okay, and the order does matter if it's a permutation. Again, the more you practice with these, the more that order matters, and order doesn't matter is gonna make sense. Let's try the next one. All right, so here in this problem, we are talking about, suppose we want 2 objects without replacement from 4 objects. So we got pencil, eraser, desk, and chair. We're picking 2 of those objects. How many different, in this case, how many ways can we do that if the order of the choices matters? Okay, if order matters, that is a permutation. Okay, so I've got 4 things and I'm choosing 2 of them. All right, so that's what I'd want to type in my calculator, or I'd want to use my permutation formula to figure that out. But that's what I would, that's what I'm looking for there. This next one, when it says order of the choices doesn't matter, all right, then I'm talking combination. And I would go, I got 4 things, I'm choosing 2. How many combinations of those can I get? All right, so I'll give you some answers real quick in case you're doing this thing at home. So I got that first one, 4. 12 ways there. And then if I go with the combination one, oops. There's only 6 ways to do that. Since the order doesn't matter, some of those orders are repeated. So there we go. That's just a matter of plugging some things in your calculator. Same kind of thing down here. Let's look at this last problem. Suppose we want to choose 5 colors without replacement from 16 distinct colors. So we got 16 things, we're choosing 5. How many ways can this be done if the order of the choices is not taken into consideration? So the order doesn't matter. Okay, so if the order doesn't matter, that is a combination. That's right. So we'd have something like this. Given 16 things, you want to choose 5 of them, plug that in my calculator, boom, pop out an answer. If the order of the choices is taken into consideration, if the order does matter, that's a permutation. All right, I'm gonna plug that into my calculator, boom, pop out an answer. That's all we got to do on these. Good luck.